Here we go. This is lecture 1 of Computer Science E76. Tonight's focus is on HTML5 continued and in laying the foundations for the first project if you have not yet dived in. A couple of announcements. So sections, recall, are an opportunity to work more intimately with one of the teaching fellows and some classmates on Q&A, on project ideas, on additional examples related to the week's material. A schedule for these is up here. Typically, as we announced last week, they will immediately follow lecture, simply to minimize commute needs during the week. They will be filmed, so if you need to take off or you're not in fact here right now, those will be available online within 48 hours. And then occasionally on Wednesdays will there be walkthroughs of the project. So for the staff's choices of projects where we specify exactly what the design goals are for the project, Tommy McWilliam, the course's head TF, will walk us through those projects. And those will typically be on Wednesday evenings. And if you're able to make those, terrific. If not, those two will be filmed. And those are meant to answer the question upon reading the spec, where do I begin? So those should prove a nice resource as well. In addition, these are ancillary to the course, but if you'd like to get to know more of the community in the context of iOS, Android, web app development, know that on the course's website, under resources, and this should soon, if it doesn't already, redirect to the resources page, we've maintained a list of local groups. So if you're local to Cambridge and want to get together with similarly tech-minded folks over drinks or over talks, realize that there's a number of popular groups in the area. All right, and here we go. So imagine that the goal at hand is to actually design a website for the course. And we're going to keep it pretty simple. We want it to be mobile friendly. We want to provide links to the most useful resources. It's actually pretty easy to make a mobile website. So we talked about this last week. What is involved in making a mobile web application or website? What skills do you need? CSS, HTML, right? You probably just need the skills with which you entered this course or one like it. So it's not all that hard really here, except that you need to keep in mind that the use cases are a little different. The user input mechanism is not a precise arrow. It's actually someone's finger. And so something like this probably, though readable as it is, it's not necessarily an optimal implementation. And in fact, we've at least given some thought in this implementation to the matter of font size, because indeed, if you simply wrote up like a CSCIE76 tag and an unordered list, but left out certain key HTML elements, what might a screen like this look like unintentionally? It's super small, right? You recall that the browser would typically assume sort of normal desktop browser width, and the simplest of meta tags can actually help ameliorate that. So recall that we did introduce last time these very simple tags, a meta tag for the viewport, the content of which can actually include some number of these attributes here. And the one in question here is width. And if you set width equal to device-width, recall that device width is just a special symbol, if you will, that the browser assigns a meaning to, 320 pixels, 240 pixels, whatever the case may be, so that the viewport is actually sized accordingly. So there's a number of mobile websites that even I sort of accidentally stumble upon from time to time through various blogs or Google News that make unfortunate use of some of these other additional meta attributes. Have you ever visited a website on your phone or Android phone, mobile phone, or the like, and you pinch, and it just doesn't do anything? Maybe? Yes? No? So take note of these things. It's infuriating, and it's a horrific design decisions by the author, because what they've probably done in those cases is made use, for whatever purpose, of this little attribute here. User scalable equals quote unquote no. No is bad, right? And frankly, I've been hard-pressed to ever understand why a website would say you have to look at it at this size or not at all, but realize that you do have this kind of control. Similarly, can you specify how far out you can zoom, how far in you can zoom based on pinching factors, and that all pertains to here. So in general, bear in mind that these are now powers we have under our control, and they're often or sometimes not used for good purposes. All right, so let's focus for just a moment on some Safari-specific things. So much like in the late 90s and early 2000s, where all the various browser manufacturers haven't quite all agreed on how to do things, even when there are recommendations like HTML4 and HTML5, well, everyone's at it again. And in particular, Apple, in their design document for Safari, both for desktop publishing and for mobile publishing, has a number of features, meta tags, and other such attributes that you can use when making HTML markup that will get the website to behave in a, frankly, Safari-specific way. So even though Safari is based on WebKit, which is an open source browser that Chrome and others are also based on, we still have to be mindful of these kinds of things, but they can lend themselves to a better user experience. So this thing here, this meta tag, Apple mobile web app capable, content equals yes. Does anyone know what this feature will do for you? Oh, all right. So new feature at least, yeah?
It might automatically scale depending on if you're on an iOS or...
Oh, it's not a bad thought. Would it automatically scale? Not quite. It actually refers to something a little different. And it's probably in a feature that most of us tend not to use. And I think this came up even last week in passing when we first discussed mobile web apps. How many of you have ever visited a website on your, say, iPhone or Android that you really like? And so rather than just bookmark it, you also hit the appropriate button to add an icon for it to your home screen. Anyone? Yeah, so 2, right? 3 in a room full of like mobile web developers. So imagine your significant others or kids or friends who are even less technical not even realizing this is possible. So this is one way to sort of simulate the experience of having a native app in as much as most users probably equate icon on my desktop with whatever native application, even though it's effectively just a bookmark. But at least Apple has created this opportunity whereby if you do coerce or entice the user into clicking that icon that says add to home screen, well, you can control the resulting behavior. And this is actually kind of compelling. This particular meta tag will ensure that once that icon is added to the home screen, when you click it thereafter, it doesn't just behave like a traditional bookmark whereby Safari opens and you go to that web page and from there you can navigate anywhere else on the internet. It actually disables and hides permanently the address bar at the top of the screen. So it actually does start to feel much more like a true application. And even though it's using Safari, that detail is hidden. So if you visit a number of mobile-friendly websites these days, especially those that are linked from Google News and the like, you might sometimes see, even on Google News itself, a little popover using CSS and JavaScript that says hit this button. Keep an eye out for this too, because what these websites are often doing is detecting, oh, you're on an iPhone. I know the dimensions of the iPhone screen, which means I can absolutely position with some CSS and or JavaScript a little banner message at the bottom of your phone that even points at the very specific icon that most of us don't even know is there. Right? So you can at least, if the cost of developing a native app is so much higher that you'd rather just incentivize people or educate them on using mobile web apps, that's one trick that some sites have been using. Though if you're like me, you usually just dismiss that screen anyway and don't bother going through those, jumping through those hoops. But this is the tag that makes that magic happen. And when it's added to the home screen, it just works in that way. So you can do other things. This one's not nearly as exciting, but you can control, for instance, the aesthetics of the toolbar up top in an iPhone at least. Normally it's gray with your carrier status, battery status, and the time and whatnot. You can make that black, for instance. So at least you have a little more control over what the aesthetics of your mobile app is when trying to present it as something a little more native. These are a little more compelling. So much like websites for years have had fav icons for the little icon next to the toolbar, similarly can you do things with the icons that end up on the user's home screen. So by default, Safari will typically look for a predefined name, namely Apple Touch Icon or another variant thereof. Or you can specify it explicitly with a link tag so that if the user does in fact bookmark that page onto their desktop, you can control the icon that appears. So it's not something silly like a big white icon or the like. Or by default, if this doesn't even exist, Safari will take effectively a tiny little screenshot, which probably is not all that compelling, and use that as the icon, as the button's icon. So this too allows you some fine-grained control. Realize for those who are more graphically oriented that by default, if you just provide like a 57 pixel by 57 pixel square image to use as an icon, even if you're not very good at Photoshop, well, the iPhone itself will add the sexy little reflection at the top of the icon, giving it a nice 3D effect. And if, though, you'd rather do that kind of detail yourself, you can pre-compose the image. Make it in Photoshop, make it sexy and shiny and 3D-like, and just tell the device, use that. Don't try to beautify it further. further. So you have some aesthetic control there. And lastly, if your application is particularly slow to load or just has lots of data, you can actually control the user's experience even while a large JSON object or a number of libraries load with a startup image. But there are perhaps more effective ways of doing this. We talked briefly last week about how Gmail asynchronously loads the rest of itself so as to show the user something immediately. So there are alternatives like that. So let's take a look here. Let me go into a web directory. So I happen to just be using a virtual machine here that's running a web server just so that I have a place to put these files. And I'm going to go into lecture 1. I'm going to go into app. And here we have an example that's somehow going to involve Tommy. So here is a very simple HTML5 page. What characterizes it as HTML? It's a little cut off, but I do have open tags on all of these things. It's the doc type. So those of you who've been doing web development for some time know of the god-awful HTML4 and XHTML doc types that to date I have never once memorized and have just been copying and pasting for years. So someone finally realized that maybe we can do better, and indeed this is better, whereby that tag up top, doc type, specifies to a browser, hey, here comes HTML5, or at least here should come HTML5. Thereafter, the syntax is almost identical to HTML4 and even some features of XHTML, but we're back. XHTML seems not really have caught on among the masses. So this effort toward opening and closing every one of our tags, whether with open tag, close tag, or open tag with a slash inside of it, hasn't really caught on sufficiently. So we're back with HTML5 with some tags not needing to be strictly closed. And those are the ones with which you might already be familiar. An image tag, there's really no notion of starting it and stopping it. So that can be a singleton without any corresponding close tag. So what's interesting here? Well, we have apparently very little content here. We have an image tag that simply references some ping on the local disk. And then we have a link tag that references some kind of custom icon.ping. And then we have copy pasted up there 2 tags related somehow to the user's experience graphically. And then lastly, the viewport, which we saw last week, specifying that the width should correspond to the device's width, not to some much larger resolution. All right, so let's see what the end result here is. Let me go to a browser. Let me go into app. And there we go. That is my mobile web app. Very underwhelming in Chrome here. But let me instead try to do this. Let me instead switch over to Mac OS. Let me pull up the same site here. And pull up app. OK, so same effect, this time on Mac OS. So I've now officially tested it in 2 browsers, though not quite the same idea. And then let me go ahead and pull up the iOS simulator. So this is something you don't strictly need at this point in the semester. But if you already have a Mac, it's indeed useful, even for the web aspects. Let me go into the appropriate directory here. All right. Source 1. My project, as an aside, and maybe just to build suspense, my project for an hour last night was trying to figure out in Lighty, which is the web server we use for the CDN, how to add that device with meta tag to the dynamically generated directory listings that happen whenever you don't have an index.html file. So as of yesterday morning, this website always looked like, let's see if I can simulate. It was near impossible to click on anything until now we have practiced what we preached and figured out how to insert that dynamically. Anyhow, no more suspense. Here we have Tommy. All right, so very nicely sized for the web page. And if I scroll up, kind of fits perfectly. But suppose now I want to click this elusive button. So here I can tweet him, print him, add to home screen. Let's do that. And Tommy app. And notice Tommy comes with a custom icon. So let's go ahead and click add there. And now in the simulator, you can see all of my other failed demonstrations where I just got white icons accidentally. So now if we click this, now the end result is 1. Status bar up top is black. It's kind of interesting. But if you click and drag, this feels much more like an application. So this is why these various websites are trying to incentivize folks or convince them to actually click on that, because you can approximate the experience of an actual native application if you can just get the user to cross that hurdle initially. Any question on the HTML aspects, tags, or the like? That's a lot of Tommy. OK.
This is all Apple. Is there something similar in the Android world?
It's a good question. Not to the same extent, to my knowledge. Apple's really gone sort of above and beyond in trying to control the user experience. But for the most part, I don't believe you can disable as many of these details as you can in Safari-based WebKit.
So
yeah.
Only the status bar where you enter the URL, that stuff is hidden. Everything else is the same as HTML.
For the most part, yeah. It throws away some stuff that would otherwise genericize the app as just being an open web browser. So this is pretty much what you get. Yeah?
Are you able to, is there a back button in any of that functionality, or are you just locked on this page? Do you have a link, say, on that page to another?
Then it's up to you to start providing some of that functionality. A lot of the Chrome, so to speak, of the browser does disappear. And I should mention, too, because we did see an example last time, I think, where I pulled up. Let me pull up Safari proper this time. So if I go to, let's say, fair.cs50.net, this was a mobile web application that we put together quickly for a special event last year. Oh, that's not going to work. That's very meta. OK. OK. So notice this. So this is still just Safari. We did on the actual kiosks or on people's phones, we encourage them to just make a bookmark. But this was a one-time event, so less compelling. But we did hide the address bar here. And this is compelling for websites to do. Gmail, gmail.com on a mobile phone does this. And a lot of websites do this. They seem to have eliminated the address bar altogether. How? This is not the result of a bookmark. Recall that I just manually typed in the URL. And yet, no address bar. Feels like a more native-like mobile app. And yet, there are back buttons and such here.
Hidden div?
Hidden div, so not a bad thought. Not, in fact, the case. It's even simpler than that. Different meta tag would be nice, but it's actually more hackish than that. So it's sort of, normally the address bar is up at the top. If you wanted to hide it, what would sort of the most naive, simplistic human do? Just scroll, right? Scroll about 20 or 40 pixels. Well, that's exactly what these websites do. You have a small snippet of JavaScript code that fires 20 milliseconds or half a second after the website itself actually loads. Whoops, zoom up, and voila, the address bar is hidden. Yet it's still there, because if I do click and drag down, well, there it is. All you did was slide the web page up. So these are the kinds of workarounds, or dare say hacks, that folks have resorted to at least make, one, more use of the screen real estate, and two, really just clean up the UI. Even I, when I see the address bar there from a UI perspective, just feels messy to have the address bar there and then these buttons up there. And so per last week's chat about native versus web apps, these are just a lot of the little things that start to add up when someone tries to make the decision of whether to invest in something web-based and support a whole bunch of platforms, or maybe just sink your time and or money into something iOS or Android or Windows Mobile specific.
What does HTML5 extend itself to have the capability?
It's a very reasonable question. Why not just integrate some of these features into HTML5? Maybe that's where things would end up. But the W3C is not known for moving quickly. And even now, there's a number of things that are not fully standardized across browsers. So would be great, but
This seems like a lot of hacking.
it does. It does. So sadly, this is the state of the art with at least some of these mobile web type techniques. All right, so let's toggle back here and see how we can do better. Right? So admittedly, that was a little hackish, but things at least feel a little less hackish if you hide these details under the guise of some framework or library. And indeed, we can simplify a lot of the tricks that we just manually implemented by actually standing on the shoulders of some fairly popular mobile frameworks that are aspiring to just make, one, mobile web development easier, and also, two, the output just look better. And by better, I would generally mean more like a native experience. So three of the most popular frameworks right now in varying states of completion in beta are jQuery, jQuery Mobile, Sencha Touch, and if you Google around, there's some other players out there. jQuery Mobile is pretty nice, particularly in that it's meant to play nicely with jQuery itself, which is fairly omnipresent these days. JQ Touch, which has a relationship with Sencha, which is a company, is still in beta of one form or another. Sencha Touch is actually fairly full-fledged, and I would definitely recommend Googling either now or at some point the various capabilities of these things. Much like desktop-based JavaScript libraries, you get a lot of widgets, buttons, and icons, and transitions, and the like that just allow you to focus on the interesting parts of some project and worry a little less about the GUI aspects. And certainly, if we scroll back to where we started the conversation with this thing, surely we can do better than this. And indeed we can with just some simple script and link inclusions and possibly some method calls. So let me actually go ahead and do that. Let me toggle back over to our to Tommy here. Let me go out of the app directory and this time go into CS76. So all of this code is available on the course's website if you'd like to play around. We have a CSS directory there, slightly cut off, a framework directory, and an HTML directory. Let's start with the simplest of them. This HTML directory means just that. This entire mobile website is implemented just in HTML. So let me go ahead and pull up lecture 1, which is going to be in here, lecture 1, HTML. All right, so this is where we began the story. And this is the same thing that the screenshots of. If I go ahead and click lectures here, we see lectures.html. If I go ahead and click here on lecture 0, we see the following links. And if we then click on these, we should actually see that those slides were not posted, but we do have this video here. And so we could see what happened last time. All right, so on a mobile device, that too should trigger the opening on an iPhone of YouTube. So it's actually fairly well integrated just by recognition of the MIME type. But this really doesn't feel like a mobile app. And my finger can't really distinguish all that well two blue links that are so close to one another. So how easy is it to approximate the experience someone might expect to have? Well, let's do this. Instead of just using that HTML version, which looks, as before, pretty simple. Just plain HTML, albeit with this tag just to make sure that things are readable. What if we instead introduce just a tad of custom CSS? Let me go back to the command line here, into the CSS version of this site, and open up index.html here. So the only difference between these two versions, same exact content, same exact tags, is the addition of this link tag to ios.css, which is a CSS file that aspires to make divs and h1 tags and LIs look much like their corresponding implementations on an actual iOS device. So now, and let me I'll resize Chrome just to resemble a phone, just so we can keep using it here. So now, definitely more approximate to an actual phone. Let's click on lectures. Now let's click on lecture 0, click on video, and the video player would start there. And we could do this in the simulator as well. But what is it not doing? Looks like an iPhone, but yeah, transitions are completely absent. This is sort of old school page transitions where you go from one file to the other. You see a little white flicker, maybe a little spinning icon, depending on the network speed. So you don't get that. The back button similarly doesn't give you the opposite transition from left to right or right to left. So it's not bad, but it's not quite what users have come to expect in these devices. So let's take things up one more notch. Let me go in this time to the third directory called framework. This time it's just a single file, because what's interesting now is that this example uses a library called jQuery Mobile. So this is from the same group of jQuery. Notice that I've included a few libraries up top, both the jQuery library itself, followed by the mobile library, and then a style sheet for the last of those. And then we still do the device width thing. But notice that my page design now has fundamentally changed. I now have many more divs. But each of these has some new attributes associated with them. So one of the nice things that was introduced with HTML5 is the allowance for arbitrary attributes that developers can add to any element so long as it begins with DATA hyphen. And you can then use these tags and still pass validation if that's something you care about. I would say the W3C's validator, but still leverage those attributes in your own JavaScript code or CSS. So in this case, the folks at jQuery have decided, all right, well, let's try to model the structure of a page in a standard way, in a way that's a little cleaner than using CSS classes, which is sort of the workaround that the world has used for some time for the same kind of modeling. So up here I'm going to have a div tag whose role is that of page. So page is arbitrary, but just semantically makes sense in that I'm trying to model a page. So that's what they came up with. And then they decided, all right, pages should have divs inside of them whose role is header, or whose role is content, or whose role, if we keep scrolling down, is footer. But what's interesting now is that even though the rest of the HTML markup is almost identical, notice that I'm no longer linking to lectures.html as I was in the previous example. Instead, I'm linking to a fragment ID. So in the desktop world, what do these fragment IDs typically do? If clicked?
Jump you to that part of the page.
Yeah, exactly. If you've ever clicked on a link on a web page that's pretty long and it starts with a hashtag, that scrolls you down rapidly to a certain point in the page. And that was meant to allow users to hyperlink within a page. So that doesn't bode well here if all of a sudden my UI is going to start sliding, but up, down. But that's not, in fact, the effect. Instead, we're just using that so that when clicked, it does not trigger an HTTP request, but rather it can trigger some JavaScript and or CSS to kick in. So let me scroll down past this page, and what do we see? Well, a second page. So this is all within the same index.html file. We have a second div whose data role is also page. It has a different ID, though. The first one was index, I believe, and this one is lectures. We again have a header, which this time says lectures, and another content, and so forth. So you can probably guess where this is going. What's the next page going to actually refer to? Lecture 0. Lecture 1. So admittedly, a lot of copy-paste or maybe dynamic generation of HTML server-side if I had a database and I was just dynamically generating all of this, but more on that design decision in a moment. But notice again the use of some fixed absolute URLs, but there was a whole bunch of those fragment IDs. So what's the end result in using jQuery mobile to implement this idea? Well, let's go into framework. And now, looks like it did before, but if I proceed to click with my finger, or in this case the mouse, on lectures, I'm getting a little more of that more user-friendly experience. I can click on video here. It's going to start playing. If I were on a phone, I could spin it around and it would actually play right. I can click back. But there's a couple quirks here. That didn't feel quite right, right? All right, so I can go to slides here once we post them from tonight for lecture 1. And so forth. So in short, we get a little more, but yeah, it's imperfect, certainly. And that's, in part the fault of the library, but in fault the capabilities that we currently have at present. And if we did load this in an actual phone, you would still have the issue of the address bar being up there. OK, you could hide that by just moving things up 40 or so pixels, but these are the trade-offs. So a question on design now. So this is a pretty big index.html file. Feels like there's a lot of redundancy, therefore, in a lot of the HTML, especially for lecture 0 and lecture 1. Is this good or bad? And what would you propose as an alternative to having the user download a pretty big, let's say, index.html file? What kind of factors should weigh into this particular design? And assume, logically, that there'll soon be a lecture 2 and a lecture 3 and a lecture 4. So this is the path that we're now on with this design. OK. OK, good. So certainly if we've got this data in a database or an ASCII file or an XML file, we can at least, with some PHP code, Python, whatever, spit this code out. So we at least don't have to resort to copy paste. So that's one thing in its favor. And your comment was? The
same thing with using include files.
Using include files so as to at least incorporate dynamically some common content, like the header and footer, or at least the structure of the page. Sorry? Some type of, and what do you mean by click function? OK. So if we are concerned on this scaling, and if we add in sections and we add in walkthroughs, like this file might start getting pretty unwieldy. And just keeping track of it, if it is done by hand or programmatically, there's more pieces to then wire together with these fragment IDs. Well, why not just download a minimal set, just the main menu, sort of a la Gmail, per last week's chat, and then use Ajax, which we'll talk about more in a bit, to actually request that data dynamically. And also, that is one of the features that jQuery Mobile allows. You don't have to know a priori exactly all of the content you want to display. You can do exactly that. Trigger the library to make Ajax calls. As soon as it comes back, then the transition will happen, and you'll actually see that content. So in fact, that's how that CS50 Fair app works. You see all the menus of names and all of the menus of categories by default, because we download all of that the very first time you pick the app. But we didn't want to then download 600 students, paragraph-long descriptions and links and images and so forth. So the very last page, the leaves of the tree that is that application, that's fetched dynamically, just to avoid downloading hundreds of kilobytes.
Is jQuery Mobile using jQuery's Ajax?
Is it using
jQuery's Ajax?
Exactly. jQuery Mobile uses jQuery's Ajax implementation to do all of this.
Do you include both jQuery and jQuery Mobile?
You do. They are separate. So jQuery Mobile has jQuery as a dependency.
It does have it.
Yes. Yes. So and you can. I'm sorry?
Inherits from it.
It assumes that it exists, its functionality, and its own functions are separate. It's built on top of jQuery. Without jQuery, it could not do exactly. So, and using it is literally as simple as that, one followed by the other. Yeah?
What's the issue with, because jQuery can be kind of bulky sometimes. What's the issue with downloading it on a device?
So that's a good question. The bulk of jQuery and the implications then for performance, it's definitely a reality. And jQuery does tend to come all in one fairly huge file. So you can mitigate this. And actually, before I answer, how can you mitigate this concern over size and the re-downloading of this huge file? So there is caching, and you'll get that sort of automatically for free, and that the first time you do visit your mobile website, that file will come down with all of the others. And so long as you haven't customarily configured some headers to say don't cache this static file, it should remain in the cache at least till the browser evicts it. And you can actually cache even more effectively than that. This is actually deliberate, the fact that I've used this URL instead of just quote unquote jQuery min.js. What's the implication of using this much longer URL in the headers?
It's a stripped down version.
So it is a stripped down version. So in JavaScript, there's this notion of minification, whereby you throw away unnecessary white space. You change foo to just f as a variable name just to save bytes everywhere you can. And you do this programmatically with the command. You don't write your code this way. So that's one approach. And
Using the latest version.
using the latest version, OK. But that particularly doesn't help.
No.
But I am using whose version or whose copy. Yeah, so I specifically went to jQuery.com, skimmed the documentation, found the recommended link to use. And unlike some libraries, they don't encourage you or require you to download the library yourself and then unzip it and put it into your project. They've committed to hosting this as on a CDN basis, Content Delivery Network. So that the idea is that if you and thousands of other people are at least using the same URL, yeah, someone's going to bear the brunt of downloading it for some number of milliseconds or seconds. But if like dozens or hundreds of websites are all referencing the same URL, the browser then can cache it globally because it's going to realize, oh, I downloaded that yesterday for some other website. I'll just use the same content because the URL is identical. So that tends to be one of the upsides of using a CDN. Do beware, though, mixing. If your application is HTTPS, mixing in HTTP content, especially with desktop browsers, but even mobile browsers might not like the coexistence of them.
You're specifying a version. Is there a way to just say give you the latest?
I think so. I don't remember if they do that on their CDN. Google might, though, and Yahoo has a version of this as well. I suspect as much, though generally I would probably recommend hard coding the version because if some feature changes, if some bug gets fixed that you were counting on not getting fixed, exactly. You don't want your site to be to break in the middle of the night because jQuery updated itself. So I would just beware with that. All right, so yet another approach to implementing a more compelling workflow. So for the Student's Choice projects, realize in general, as we introduce, not just in the mobile context, but in Android and iOS, even if the staff's choice of project doesn't mandate using one or more of these frameworks, realize that the Student Choice ones are an opportunity to go off and experiment with something of interest to you. So a bit then on what you will need to know for the first project and really for mobile development in general. So typically, the class has a mix of folks with and without this experience. So please forgive anything you know, and please enjoy anything you don't. Just to get some jargon, though, underneath everyone's belt. So here's a snippet of fairly uninteresting HTML, HTML5 at the top left corner. And it's interesting in that there's clearly some hierarchy there. I've pretty printed it to reflect that. And we have inside of HTML a head tag whose descendant is a title tag whose descendant is quote unquote my title, and then we have some other tags there. So in JavaScript, if less familiar or unfamiliar with this language of choice for the web, realize that this can be represented in memory by a browser as a tree. And you can kind of see that if you kind of rotate your head and just recognize the hierarchy at left and think about the root node as being the HTML element, inside of which is nested all of its children and descendants, the head element and the body element. Now, in reality, you kind of need a one uber node above even the HTML node. Even though there's one root element of a web page, there's also what's generally known as the document node, which allows you to put other stuff at the top of the file. Comments, things called processing instructions, but comments really are the things you tend to see these days. So you need that special root node up there. And then thereafter, this is just an artist's rendition of how we might draw this page. Notice, though, that the up-down relationship suggests parent-child, and the sideways ones are just a way of depicting that this element here, the anchor tag, has an href attribute, but it doesn't really belong vertically beneath it. For what simple reason? It's not a tag, it's not a child, and if it were below, it would just imply that it too could have children, but no, it's a terminus. So attributes we might just draw hanging off of this. So who cares? Why is this relevant? Well, for many years, before jQuery came along and became particularly popularized, we were pretty much stuck with using what are called DOM functions. DOM is Document Object Model, DOM in all caps, and this just referred to a suite of functions that were largely standardized, at least in terms of their signatures, by the W3C, and they compelled you to navigate DOM in a fairly annoying way, to be honest. You can go from parent to child, but then you have to iterate over each of the children as though it's in a linked list. And it just was not nearly as easy as jQuery, for those familiar, allows for you to do. Selecting IDs with hashtag ID, or selecting classes with .foo, or the like. So these days, frankly, jQuery has kind of been, for a lot of people, just synonymous with JavaScript in that it just makes the language easier to use. But even still with jQuery, as you traverse various elements in a page or use CSS selectors to go from parent to child to grandchild and so forth, what you're really navigating is a structure in memory that looks like this. So understanding that every page can be represented in this way should hopefully make jQuery and JavaScript more generally a little more straightforward. So for those a little less familiar, you can include JavaScript in a mobile website in a couple of ways. One, you just have a script tag somewhere in the body of your page or even in the head of your page, and then you put your code right smack dab in the middle. Among the niceties now with HTML5 is you don't need to resort to these hacks of using CData and / and all of the little trickery that people started using for some number of years to actually avoid a browser confusing JavaScript code as like an angled bracket for a tag, right? It's sometimes nice to say if x is less than y, but unfortunately less than is a special character in HTML, so things used to break. With HTML5, folks have recognized this is kind of a common case that we should allow for. You also no longer need to specify to be valid a type equals quote unquote text JavaScript or the like, so things have just gotten a little simpler. Things to keep in mind, whether in a mobile device or even desktop browser, when you do add things like, say, Google Analytics to your website, which typically need to go in the body of the page, where in the body should you typically copy and paste various such libraries or widgets, script tags? It's the bottom. Why at the bottom?
Outside the form?
So outside of a form, but it's outside of a form is not strictly necessary, but bottom is what's compelling. Yeah? Yeah, exactly. It's generally for performance or for any bugs in the actual page itself, whereby a web page will typically load all of the content within it, all of the href tags, all of the images, the script tags, and the like, really top to bottom. And so if any one of those hangs for some number of milliseconds or seconds, that's where the page is going to hang for some time. And if the page starts hanging too soon, well, the user is literally just going to see a big empty white page or the contents of the previous page that they're trying to navigate away from. So the downside here is that this is so commonly done, right? There's all these third-party advertisers these days. You go to most any popular website, there's ads up here, up here, up here, up here. And what a lot of these advertisers do, or less technical folks, is just plant the script tags where they want them to go, where they want the content to go. The downside is if DoubleClick or some similar advertising network is down or overloaded or slow, it really just screws up the loading of the whole page. So what can you do? Well, you can put a div tag where you want the ad. You can put another div tag up here. Give them an ID, though. Put the source code at the very bottom of the page so that asynchronously, once the whole page is loaded, then you go back to the ad server, get that content with a simple Ajax call or whatnot, and then just plug it into the div whose ID is X or Y or Z. So very easy things to do that make all the more difference in a mobile environment if really you want the user to at least think that the website is zippy and interactive, even if it's downloading yet more content in the background. Now, with that said, libraries like the ones we just talked about typically do belong in the head since they're so integral to the rendering of the whole page. It would be nice if the user sees the intended page and not some very generic version that suddenly beautifies itself some number of awkward seconds later. So we've seen this format before as from those frameworks. So JavaScript, we won't spend much time on the language itself since, for the most part, folks do tend to come in with background. And also, whether your background's in Java or C++, C#, or the like, syntactically it's quite similar to a lot of the languages with which folks are similar. This is just a very short laundry list of the constructs, if only to assuage that you're familiar with most all of these ideas. There are object-oriented aspects of it. It's not a class-based language, but what's called a prototype-based language that we won't spend too much time on. But in the project spec, one or more of the readings actually do go into more detail as to the design of the language and its capabilities. It does have support for exceptions, but most every other statement there should be fairly familiar, whatever your background. Arrays. So what is compelling about JavaScript and what is incredibly well leveraged these days are its simplest of data structures. So the nice thing about JavaScript, if only syntactically, is that to get an array, you simply say open square bracket, close square bracket, and that's it. So you can say var x equals open brackets, close square bracket, bam, you now have an empty array in memory. And a comma-separated list of things can go inside of that. But even more compelling, though, would be to use its objects. So really, JavaScript's contribution to humanity and data exchange has been the simplicity of something called JSON, JavaScript Object Notation, JSON. So this has really come onto the scene. It's a much more compelling alternative to what for Ajax? Sorry? Yeah, so the X in Ajax once upon a time was XML. But the reality is it's just a pain in the neck to make Ajax calls, get back an XML object that, yes, can be depicted as a tree, but then you need to use these damn DOM functions to actually navigate that tree. Whereas with JSON, inasmuch as it's just a collection of key value pairs, JavaScript, to allow you to access an object's property or a property of that property, it's very trivial dot notation. There's no method calls. There's no traversing of children or parents or siblings. You simply use the dot notation typically to go from one object to its property to another. Similarly for embedded method calls. And for some examples, I'll defer to the recommended reading, but we will see these in use in just a moment. So what is Ajax? Here's a technical picture, but in real terms, what is it? Dare say layman's terms. OK, synchronous library call. What do you mean by that?
I don't know.
OK.
The whole intent of Ajax is to not have to refresh the page.
OK, true. So the overarching feature that Ajax enables is not needing to reload the whole page just to get more content. And I should prefix one word you said. So it's actually asynchronous. The asynchronicity of Ajax is what's really compelling. And what does this mean? Well, asynchronous generally means in this case that even after the page is loaded, you can then go fetch more content, as Gmail does in a mobile context, or as a result of user action, clicking a link, clicking a button, choosing something. You can fork off an HTTP request. But Ajax is asynchronous in that when you do call the send method that sends the request from client to server, send immediately returns, even though the internet's going to take a few milliseconds or seconds to actually get back to you. But it's asynchronous in that when the server does respond, the browser pays attention, and then the browser will invoke a function you told the browser to call when the response comes back. So this means your code can continue executing, you can continue interacting with the user, you can listen for more mouse clicks, show them more content. But even if it takes 5 seconds, additional content comes back, your handler function will then get called, be passed whatever the server responded with as an argument, whether it's an image or a piece of data, and then your function can do whatever it wants with that piece of code. And so this just depicts that same idea. So if we walk through the numbers, user interface is you on a phone or on a browser. Your browser makes an XML HTTP request. This is just the name of the this is a bit of a misnomer. This is the name of the class, objects of which are used to make Ajax calls. It's a misnomer in that it's not really a class, but it's an object named that. Step 3, the request goes from the browser to the server. The server does its thing, maybe getting some data from a database, and then responds to the Ajax library that you're using, really the browser. And the browser then invokes your event handler and says, here's your data. And at that point, you can do anything that you want with it. So Ajax is how Gmail gets new mail for you. It's how Gmail on the phone sends your messages in the background while still letting you start the composition of some new message. It's how Google Maps on a desktop allows you to click and drag, and all of a sudden you see blank gray tiles, but then they become images of more map or satellite imagery. All of that's happening in the background thanks to Ajax. So we can see a couple of examples here. So let me go into our Ajax directory and look at this relatively simple first example here. So if I scroll down, we'll see this is mostly HTML until we reach this script tag. And actually, I can clean this up a little bit since we don't need to be as proper. We can get rid of this. We can technically get rid of this. And then everything inside of this now is just some Ajax. There's any number of ways to do this. And frankly, these days, the right way to do it is probably with a library. Something like jQuery that takes a lot of the error handling that I've manually implemented out of it, that catches more corner cases than I've caught here. But just to give you a sense of what's really going on underneath the hood, both for the first project when you need to talk to the browser via JavaScript, and also when you start taking for granted things like jQuery, let's see what's here. So at the very top of my script tag, I have a variable, a global variable, if you will, global for this specific page, called XHR XML HTTP request, and I'm just initializing it to null. Now I have a function called quote. So the purpose of this website is to implement the following functionality. I'm going to go ahead and pull this up in a browser. I'll go to Ajax 1. So I have this very simple HTML form, and I want to be able to type in something like GOOG, which is Google's stock ticker symbol, click get quote, and then some number of milliseconds or seconds later, I want to see that the price as of close today was $577. And that took a few seconds in that case because it was talking to a server somehow, but then the result comes back. Now this is really an underwhelming use of Ajax, right? Ajax would be in a sorry state if to get more data and show it to the user we had to use JavaScript alerts, but it's sort of a poor man's way of showing that a function was called asynchronously once the server got back to us. So how do we do this? So here we have a function called quote. Here's how Ajax can be used. So in most browsers in the world, you can simply say new XML HTTP request, effectively calling a constructor. That gives you back a magical object that lets you use Ajax by invoking an open method and a send method. Or if you're using older versions of IE, you have to write this. And so this is a very admittedly hackish approach to using try-catch. This isn't quite what exceptions are used for, but it was a fairly robust way, certainly early on, in detecting what browser you were using and supporting both. So if this is null, we're really using an old browser. And so we'll just alert the user that this isn't going to work. But if we scroll down, we can now make use of this. And Ajax is actually relatively easy to use, as we'll see here. That's it. If I want to make, programmatically, an HTTP request to a file called quote1.php, and I want to pass in as an HTTP parameter a symbol parameter, that equals document.getElementById, quote unquote symbol. So assume for now that there's somewhere in my HTML is an input element whose ID is symbol. That's going to plug its value to the end of that relative URL. And then I'm going to say 3 lines of code with respect to that XHR object. I'm going to first say on ready state change equals handler. And just take a guess. What is handler probably representing here? I'm sorry? So it is an event handler, and specifically, what do we mean by event handler now? A callback. So there's a function somewhere, haven't seen it yet, but somewhere in this file or elsewhere, there's a function called handler. OnReadyStateChange, though rather ridiculously named for an object with so few properties, is the property that you set the so-called event handler to. So for those familiar with C-based languages with function pointers, that's effectively what we've done here. XHR open, so this is opening a socket connection, or we'll be opening an HTTP connection via get to this URL, and true here, which is optional, simply means asynchronous. So you can actually use Ajax to make blocking calls, whereby this function will not return until the connection's been established and you get back response. But in this case, asynchronous is almost always what we want. Then I'm going to actually send the request. I'm passing a null simply because I have no post data. If I did have post data, I could send it via that argument. And that's it. Notice that my code ends, my curly brace, if it's not cut off on the projector, is closed. So that's it for Ajax. So that just means we hopefully are listening for the server's response. And indeed, here's the server's response. So here's a function called handler. And we have to check a couple of things. So one, if xhr.readyState equals 4. So what is 4? There's essentially 4 or 5 states that this object can be in, either I think 0 or 1, where it's not doing anything. The next number up is it has opened a connection. The next step up is it's sent a request. The next step back is it's waiting for a response. And the fourth and most compelling step is done. Here is the data that you requested. So typically, folks will check for that one. Then we're going to check the HTTP status code, which is hopefully going to be 200, a number we never see because it means all is well. If you instead get back 401, 404, 500, bad things happened. But 200 is good. And the reason that we saw that stock price in a little silly alert window was because all I did was do alert xhr.response text. And as that property's name suggests, that's the response as an ASCII string that's then being displayed in the browser. So I could do much more compelling things with this example if I actually wanted to spice it up, which we'll conclude on in a moment here. Let me scroll down just to reveal what's going on in the HTML. This part's relatively simple. So we have autocomplete off for our input field. I did give it an ID so that with JavaScript I could very easily access it. And then the only other interesting detail here is that on the form submission, I'm invoking the quote function, but I'm always returning false. Why the false? Yeah, we want to prevent the page from refreshing. Normally, when you submit a form, then the data goes to whatever the value of the action attribute is, or back to the same file. If absent, that's not what we want here. We deliberately want to use the form, but impede its submission so as to use it as a UI mechanism, but not as a traditional HTML1 style form for an actual submission. So that's one way in which we could do this. And we could do this even more cleanly. Those of you who do know jQuery already, or even have been using JavaScript for some time, we could actually make all of this at the bottom pure HTML, but give it one or more IDs, and then programmatically with jQuery or JavaScript say, give me the form whose ID is foo, and then attach to it this event handler, namely the onSubmit. So we can factor out our code and not commingle it in this way, but this is meant to be a simple demonstration thereof. Any questions? Well, let's jump to this slightly sexier version here. So in this case, actually, let me take a quick look here. So in this case, let's do 2, then conclude with 3. So in this case, I've done one thing that's different. In the HTML, I've kind of anticipated response coming back. I don't know what to put there yet, so I'm just going to say to be determined. But I've given this span in the web page an ID of price, the goal of which now is to at least eliminate the silly little alert window that I used a moment ago to display the stock's price. So if I instead go back here in my browser to, say, version 2 of this, and then type in, let's say, the same, whoops, I'll zoom in and click Get Quote. OK, this is more compelling. And now, simple though the UI is, this is what Ajax is typically about. And what's happened now is the actual DOM, the actual tree that's been rendered in memory as a data structure, has been updated with a different text value for that particular span element. But we can do even better than this. Or rather, we can implement this in a similar way, but circumvent one issue. So in both of these cases, 1 and 2, whose server was I requesting stock prices from? So my own, apparently. And why? Well, it's a relative URL. There's no other domain name involved, so it must be whatever web server I'm running. And right now, recall I'm running a virtual machine, running Linux, so it's my own little server. So this kind of suggests that my web server knows the stock price of Google somehow, and not to mention other sites. Well, let's see what quote1.php actually is. If I go into quote1, notice that I have a fairly short program. There's not much here other than comments and these several lines. Notice that I'm using PHP, which, if unfamiliar, here just means open TCP socket connection to that particular URL. And if you've ever used Yahoo Finance, you might know that they allow you to download stock data using CSV files, comma-separated values, which is sort of like a simplified spreadsheet. So what I'm really doing is using their data with a few lines of code here. I'm requesting that CSV file specifically for Google by pasting into the URL I'm hitting on them. If I scroll to the right, Goog, I'm getting back that CSV. I'm parsing its commas and then returning to my own JavaScript code exactly what price I want to get back. And therein lies the dynamism here. I'm plugging in as the value of S for Yahoo exactly what that price is. Why? Like, why did I have to teach myself PHP and write my JavaScript code to talk to my own server, to then talk to Yahoo, to then talk back to me so I can respond to my own JavaScript code? Like, why is there this layer of indirection rather than me not just talking directly to Yahoo?
Yeah, you can't talk to another server.
Exactly. So this boils down to something called the same origin policy, whereby browsers, by design, just generally a good thing, if increasingly annoying, given the wiring together that folks are liking to do with web programming, you're not allowed, with Ajax calls, to access content from some other sites. Now, this is, you can do this obviously with images if the site lets you, and even JavaScript files can come from other sites. But if the goal is to get data from some other site and integrate that data into your DOM, that's where the line is drawn. You cannot do that unless you somehow trick or write the code in such a way that you can induce the browser to actually execute what's coming back. So this last example with Ajax 3 does exactly that. My quote function, rather than talk to my own server and my own PHP file, notice a much, much longer URL that coincidentally, not necessarily, is going to Yahoo APIs, because per the first project spec, if you've read through the PDF yet, Yahoo offers this free API called YQL, Yahoo Query Language, and it effectively is a proxy service. My PHP file, small though it is essentially a proxy server. I'm sending data to it, it's getting data on my behalf, and then returning data back to me. Well, this is a little annoying, if only because now I need an actual web server that supports PHP and execution of code like that. So why not just use a middleman in this case? So for the project, what you'll find, if you haven't already, is that you can use Yahoo, pass it the URL of some data source that provides CSV data, XML data, JSON data, and then Yahoo can return to you directly a JSON object, a JavaScript object with key value pairs, but it can wrap it in a function call. So this is what's known as JSONP, padded JSON. And the design is such that what you get back might be an object that looks like this. Price equals 577 and whatever it was. You're not just going to get that because that's raw data. What instead Yahoo will do for you is something like this. Callback, open paren, close paren, semicolon. This will be returned to you. And if you use a library in the right way, or you use the eval function in the right way, you can get this data back, evaluate it, so as to induce a function call, callback, which is then being passed data, which happens to be from some other website, but now the browser doesn't care. So this is a deliberate way of circumventing the same origin policy deliberately if the data source supports JSONP. There's another approach called CORS, C-O-R-S, whereby a web server can alternatively simply send a certain HTTP header that says, it's OK if you want to use my data in your own DOM. So that's another trick that folks have come up with. Any questions?
Why do we have that same origin?
So it's meant generally to prevent code from other sites in compromising the security or privacy of data on your site. There's a whole number of attacks that you can wage, but among them is when you have access to JavaScript code, you have access to the browser's cookies, which means you can then steal, in theory, the user's session key, which is just a big cookie. So in theory, another website could trick the user into divulging some privacy-revealing information like that, namely cookies. And then, though the code we looked at for Ajax was fairly complex, if you do start to leverage a library like jQuery, this is what things can be simplified down to. So $.Ajax is a jQuery method call that does all of that try, catch, open, send messiness that we implemented manually. It passes in this case, an object that takes a couple of keys, success, and then also URL. And as you see here, what JavaScript does allow you to do is have nameless or lambda functions so that if this Ajax call is successful, that nameless function will be executed with an argument of data, where the data is what the server responded with, and then you can do anything you want with it. So in jQuery, instead of doing document.getElementById ... you can instead just say $, quote unquote, #ID, .html data, and it will plug that data into that part of your HTML page. Yeah.
Does this mean your callback method has to deal with security-related filtering?
Does this mean your callback method has to do with what?
Have to kind of validate the incoming data.
Ah, good question. Does this mean your callback method should evaluate the return data? Yes. Well, not necessarily validate, but trust it. So this should be a conscious decision on your part. If you're going to execute code that came from somewhere else, in the worst case, it can be sending cookies off somewhere else. So in theory, you could visually inspect what the response is. But there is, by necessity, a degree of trust involved.
But that kind of defeats the same origin policy.
It does, deliberately. So this is seemed like a good idea at the time, and is for a lot of reasons. But in as much as folks are trying increasingly to make mashups or websites that really do take data from disparate sources, you can still do it yourself and proxy the data yourself. I could scrub the data myself on my own server. But that introduces a bit of latency and additional HTTP requests. So if you don't want to necessarily do that, you can get data directly these days from third-party web sources. All right, why don't we go ahead and take a 5-minute break, and when we return, more on HTML5 with Dan.
Hello, everyone. Welcome back. So before the break, we started talking a little bit about some of the interesting stuff that we can start using with JavaScript. And today, in combination with some of the fancy new technologies introduced as part of that collection of stuff that we talked about last week with regard to HTML5, can we really start piecing together some of the things that you'll really be able to use not only for your project, but also to create some really interesting, really neat web applications for your particular use. Now, I do just want to mention one thing. So tonight after class, we actually have a section, the first optional section that's actually pretty recommended if you have any questions about any of these things, and it's a great way to get some more information on all of this stuff that we are talking about. And the section will be on HTML5, and it will be led, in fact, by our own TF, Tom, who happens to be sitting over there. So do note that while we do have sections through most weeks, we will actually be rotating some TFs. So Tom is leading the one today, and we will actually have some of the other TFs leading subsequent sections later on as well. Now, some of the stuff today, though, there's no slides associated with all of this stuff because there's just a lot of code that we have to go over for today's stuff. And some of the things that we're going to be talking about are, first of all, local storage from HTML5 and also geolocation. And then at the very end, we're going to combine the two into something that allows us to make sort of a fun but perhaps a little bit creepy GPS tracker application. And so in order for us to get to that point, though, first, we have to talk about some of these technologies. So first of all, local storage is a way that we can actually save key value pairs using JavaScript on the client computer to be able to store any number of things. And it's actually a pretty neat way of being able to generate, if you are generating some data, or if the user or the client is generating some data, using a web browser for you to be able to store that information and retrieve it at a later point in time. Now, it's actually very important to realize that while this might sound sort of similar to cookies, it is in fact very distinct from cookies, in that cookies are limited in size. Generally, you can reliably only get about 4 kilobytes of information stored in a cookie at a time. And also, and the primary reason for cookies being so small is that that data is actually sent by the client browser to the server at every HTTP request. And this can be really cumbersome if you're storing an enormous amount of data that doesn't need to be sent to the server. If the client, if the user is generating data on the web browser that doesn't need to be sent to the server, there's really no need for this to happen. And so local storage is one way that we can be able to store some of this data without having to send it to the server. Now, this doesn't mean that local storage data can reside only on the client machine. You could use JavaScript, perhaps using Ajax, for example, to push some of this data to the server, but that's something that you have to do manually. This is a manual process that you must implement yourself, and it's not automatic like you would get out of cookies. And also, local storage depends, the amount of local storage that you actually have available to your web application will depend on the browser itself, because each browser might actually have different sizes available, and some browsers actually allow the users to dictate exactly how much storage can be specified in using local storage for a web browser. But generally, the spec recommends, the specification rather, by W3C recommends about 5 megabytes. So compare 5 megabytes to 4 kilobytes of cookies. You can see that we're actually getting quite a bit more storage out of this. So if we want to start doing some of this stuff with local storage, all of this source code is available online. You can actually go to the course website, take a look at lecture 1 and follow along if you would like. But you can also do that from home if you want as well. I saw a question just a second ago. Can two websites access the same data? No, it's similar to the same origin policy where it's dictated by domain. So local storage is saved per domain, and you can access on another web page in the same domain, you can access that same local storage, but you cannot on a different domain entirely access some other XYZ domain's local storage content. All right, so so if we wanted to actually take a look at how we might be able to do this, we can take a look at the very first example, data 1, which is a very simple page counter. Now, I have to say a couple of things about this. Of course, you probably don't want to use local storage for page counter, for counting visits to a particular page, because this is, of course, local. This is for one specific client, so this really is going to count the number of visits that this web browser makes to this web page. But it really is sort of a useful way to talk about some of the features of local storage and also some of the gotchas that you're going to see in just a few moments. And so this is the very first time that this particular web browser is visiting this page, so we can see the results. How many times I have visited this page in the past. Right now, it says null. So there's something going on in the background that's trying to figure out how many times I've visited this page in the past. Right now, there is none. If I refresh the page, well, it says test. That's not what we want. Oh, this is already, we can see some of the problems that are associated with this. And what I want to do is to be able to remove some of this data. So let's see. All I'm doing right now is looking for, all right, here we go. I just wanted to do this off screen, but in Chrome's preferences, and in fact, many of the web browser's preferences, we're sort of having to come to this first because it's remembering some of this content from the last time that I was using this web browser for this demo. We can actually look up all of the data, or at least the websites that are using data, and here we can see, this is just in Chrome's preferences, that looking for cdn.cs76.net, where that web page happens to reside, it is in fact, it does already have some data stored within it. So I'm just going to get rid of all of that content just so that we have a clean slate for us to work with. Okay, so that's the first time. Test. All right, so perhaps let's see. What we are storing here is not, in fact, the page counter. I'm probably getting ahead of myself, but in fact, just some very basic data. And in fact, that's what's going on. So beyond the fact that I got a little bit ahead of myself, that is going to be in the next page, we can just see a very simple example of how we can use local storage. So in this case, what we have is an HTML5 page with some JavaScript in it, and all we are doing is storing some data in local storage and retrieving some data from it. So in order to access the local storage object, it just is going to be this. Local storage, one word with a capital S and a lowercase l. Now, if your browser happens to support local storage, this object will exist, and all of the properties and all of the methods that are associated with it will come for free with that. I just happen to know in this case that the web browser that I'm using supports local storage, so I can start using it immediately. But obviously, this very simple example lacks some safety. We're not checking, for example, to see that this object actually exists before we start using it. We're just very simply using local storage to save some data and later on retrieve it. So there's a couple of things going on here. First, we have defined a function, this function here, store test. And this function is being called as soon as the page is loaded using the onload attribute of the body tag. Now, once that page is loaded, it's going to call that function, and that's how all of this functionality actually begins in the first place. Now, what's interesting, I think, is not at least in the order that we want to talk about it, it's not the first line, but it's first this second line here, local storage.setItem. We'll go to this. We'll go back up to this first line in just a moment. But using this local storage.setItem, can we actually see how we can store some data using this local storage object? And in fact, it's very, very simple. It is just using the local storage object. We use the setItem method, and we pass into it a key and a value. Yes?
Is data persistent past the session?
I'm sorry?
Is the data persistent past the session?
Yes, the data is persistent past this session. So the user can close this web page, close the browser, do whatever. As long as they don't delete the local storage database for that particular website, this same data will persist continuously. There does exist a different object, session storage, I believe, and that's specific to sessions. But in our case, we're showing local storage, and this is persistent from one session to the next. Okay, so this stores values in key value pairs. So we're setting a key here of foo, and we're setting a value of test, exclamation point. So whenever we want to retrieve whatever data happens to exist at a particular key, we just use the getItem method and pass into it the key that we want to retrieve the data from. In this case, it's the same key, foo, and we will retrieve that data, test, exclamation point from there. And then we can just display the fact that this works using an alert text box. And this is an overly simple example of how local storage can actually work. Okay, so now let's actually go to the next idea, which is the one that I was mentioning before, which is in fact the way that we can open up a, the way that we can actually demonstrate a web counter for this web page. So here we have, let's see. We have here a web page, and as soon as I load it, it brings up an alert text box. It says data is null. There's nothing in storage for the key bar. So obviously I'm using another key here, but if I refresh this page, okay, I'm still getting ahead of myself, I suppose. What we're doing now is still having, we're still just very simply creating some data and putting it into local storage, but we are now doing it perhaps a little bit better, in a little bit safer method. So first of all, we want to determine if the web browser can actually support the local storage object. And if so, then what we will do is actually use it for storing data in it. Otherwise, we'll have to notify the user that something is amiss, their web browser is perhaps not up to date, and they should perhaps use a different web browser if they want to use our web application. So in this way, we're really just making sure that what we are doing is that we are able to use local storage before we actually do it. So there's a little bit extra code that's happening here, but it's actually not all that more complicated. If we take a look again at the HTML5, we're still calling that store test function. But if we take a look at that store test function, the first thing that we're doing is calling another function, asking if the web browser actually supports web storage. If it doesn't, then we tell the user your browser doesn't actually support local storage, so this website's kind of pointless, and we will just exit without actually attempting to use those methods associated with it. Now, this function is actually pretty simple of an implementation as well, and this is one of those things like David had mentioned before when he showed at first how you might implement Ajax manually using all of the original XML HTTP request objects and all of that sort of thing, but there are frameworks that might make this a little bit easier. If you recall from last week, there's that framework Modernizer that automatically provides support for detection of each of the different HTML5 technologies and some other CSS things as well. So you might look into that if you don't want to manually implement this sort of thing. But just so that we can take a look at it underneath the hood, so we can see that we have a try-catch block. So we're using some of the exception handling within JavaScript to see if local storage actually exists in the object, in the window object, and if that object happens to not be null. So this is, in combination, what's necessary for us to make sure that local storage does in fact exist, and it's actually an object that we can use. So this is really just a test. All we're doing when we're implementing this code is just testing to make sure that the web browser actually has that local storage object, which means, and if that object is actually an object, it's not null, it doesn't just happen to exist and not actually have any content to it. And if so, then we are able to use local storage in our web application. Now, if that is true, then we will return the fact that it's true. Otherwise, we will return false. Or if there's any exceptions that happen to occur while we're actually performing that test, can we actually return false as well? Yes?
I have a two-part question.
Yes.
Can this be used with a relational database, and is it only local, or is it something that will be opportunistically synchronized with the server, or is it just local?
Okay, let me do the first question first. Does this operate with a relational database? So I suppose I'm not really sure what your question is. It's not directly. The web browser itself might implement the storage of local storage data using a SQLite database, but that's not something that you would necessarily have access to. The local storage API is this very simple key value pair using set and get methods, and that's it. That's what it promises. There are some technologies, there are some related technologies that are not local storage that do provide SQLite like features to your web application, but that is independent from what we are talking about here. Now, what was the second question?
If it's only local, or is it data that
Yes.
can be opportunistically synchronized?
Right, so is the data only local? The answer is yes. If you wanted to send data to a server, that's something that you have to implement manually in your website. That is, you would have to create, you might do it using Ajax, for example, to actually push that data from this page, or rather from the client machine up to the server. That's not something that comes for free with local storage, because the point is to keep it on the client side.
I'm probably confusing with the manifest, HTML5 manifest feature where you can if you go offline, you can save data.
Oh, yeah, that's possible with the HTML5 manifest, but this is entirely local storage. Is meant to be entirely local unless you manually override that portion of it. Okay, yes.
Can you store only strings or objects?
Can you store only strings or objects as well? And the answer is strings. In fact, that's one of the things that we'll see in just a few source examples. Hence, yes.
What is typically stored in local storage?
What is typically stored in local storage? Well, it's anything that your web application might generate that you can store as a string, and you might want to use at a later point in time. So one of them, for example, the example that we're going to have at the end of class is that GPS tracker app, for example. So we have an enormous array of latitude and longitude coordinates and accuracy, and we actually want to store all of that. And it's going to be quite a bit of data. So we could get several kilobytes of data very quickly, and it's not something that we want to necessarily send to a server, because it's something we want to be specific only to that user. So it's a very good candidate for storing it locally on the user's browser, and that user only having access to that data. And so we'll show an example of that in a little bit. Okay, so here we have this function that you're going to see throughout some of these examples that basically just makes sure that the web browser supports local storage. And if it does, then we can return true or false, and we can deal with it in that way. Now, there's a couple of other things that are different in this example as well. One of them is, first, the getItem method, if you pass it a key, for example, bar, and we haven't yet stored any data in bar, the spec requires that the getItem method actually return null. So you can actually see if you have previously stored some data in it by querying to see if that data that you've gotten back from local storage for that key is null. If it is, then you can do something. Otherwise, you might assume that some data has, in fact, been stored there. Now, so that's why that alert box came up when we first loaded the page that said that the data is, in fact, null. That's because we hadn't yet stored anything in it. Then when we refreshed the page, we could see that we had stored some data, and we were able to see the result of that as well. All right, so hopefully now in this next example, I can stop putting my foot in my mouth, and we can see how, yes, this is now the implementation where we can see how many times we visited this page in the past. So in this case, well, the very first time I load this page, it says that I've visited this page 0 times in the past. And if I refresh the page, we can see that it actually increments. Every time that I refresh this page, we get that additional information from it. Since this is, in fact, something that's not that difficult to implement using local storage. So here, if we just take a look at these, at the code, we can see that again we are calling store test, and in store test, what we want to be able to do is first load the data from local storage to see how many times we visited this. So basically what we're going to do is store this data, how many times, this number, this value n, that represents how many times this user has visited this page. We're going to save it in local storage and retrieve it every time this page is loaded, first of all to show that alert box, and second of all to increment this counter, and resave that data so that for subsequent loads we will be able to determine that same thing. So first thing that we do is to load the count variable, or rather the count key from local storage, find out if it's null. If it's null, then that means that we have not visited that site in the past, and so data in this case we are going to override as being null to 0. Then we can just show this alert box that you visited this page n times in the past, or rather count or data times in the past, which represents how many times we have actually done this. Now after that, we can then update the local storage by incrementing the data variable and storing that data in local storage. Now you'll notice something about this, and that is that there's two ways that you can get and set data in local storage. One of them is using that get item and set item method, but you can also treat local storage as an array and use this square bracket notation as well, which you might be familiar with from other languages or even within JavaScript, PHP, any other of these languages that implement arrays in this way. You can use this and it will in fact work the same way. So we can, in this case, instead of using local storage.set item and then providing the first parameter as the key and then the second parameter as the value, we can actually say local storage and square brackets count and set that equal to the data that we actually want to store here. Now, before we had the question of what actually happens or how is this data actually stored. So I added an extra link here that says mess up counter. This link just calls another JavaScript function that's going to corrupt the data within this local storage or within that count key in local storage. So we can see now what happens as a result. I messed up the data in the local storage object, and I reran that same function before, which actually tells me how many times that I visited the page. So we can see you visited this page test times in the past. And now if I refload this entire page, recall that what should happen is that it should increment that value and should tell me how many times I visited it. But now look at what has happened here. Now it says you have visited this page NaN times in the past. Now, NaN, if you're not familiar with JavaScript, represents not a number. And that means that I'm trying to perform some arithmetic operation to something that is not, in fact, a number. So in this case, I'm trying to do that plus plus. I'm trying to increment some value that is not, in fact, a number. And you might recall that the thing that I actually saved in local storage was that string test. And we can actually see here that very thing. What's happening is that now, in order to mess up what I called corruption, was to just remove, was to obliterate that data and instead input this string text. Now, the reason that this is important is that what I had before was actually really poor code. I mentioned that the data is actually stored as a string and not in any other format. So what's happening here in this code that actually retrieves this data and increments it right here using this plus plus data is an implicit type change from string to an integer. And when I don't actually explicitly change it, I'm giving myself the opportunity to mess up this data by replacing it with something that cannot easily be parsed as an integer. So in this case, I just put in the actual string, and now every time I try to do this in the future, it is in fact going to fail. So there is a way that we can try to overcome this problem, and we can see now how we can fix this problem with the next source. So in this case, there's a couple of things happening. The very first thing that the alert box shows us is string. We're going to show you why that's important in just a moment. And we can see, and so Chrome can tell that my web pages are being a little bit chatty with all of these alert boxes, and it's asking me if I want to prevent this page from creating additional dialogues, but I'm going to ignore that for now. Now we can see that I visited this page 0 times in the past. If I keep refreshing this page, we can see the same thing, and it's actually doing the counter properly. But now what happens if I click this same mess up counter function, which does the very exact same thing that I mentioned before, it no longer says you visited this page test times in the past. It does still actually say 0, which means that it's detected perhaps that there's been some corruption or been some problem with the local storage, and it's reset the counter to some integer value that allows me to continue using this without getting that not a number error that we saw before. Now, you'll notice that that first pop-up that always came up was something that actually listed a type. It just said string, string, string every single time. That's because no matter what data is actually stored in local storage, what I'm doing, the very first alert box is actually telling us what the type of data is in local storage. So if you didn't believe me before, this is some more proof that, that what I'm saying, at least in this case, is true. And so here we can see what is happening. Oops, I guess I should change to data 4 in order to see what's actually happening here. So what I'm doing now is first setting an alert box to tell us the type of data that's stored in local storage count. And in all cases, it doesn't matter if it was actually a number 0, 1, 2, so on and so forth, or if it was the string test, it always said that it was a string. So what I need to do then is to explicitly typecast, explicitly convert this data, this string, into an integer. And then I might be able to know for sure whether or not that conversion happened successfully. And so I'm using then the parseInt function that comes with JavaScript on that data, on local storage count, to try to capture that string and convert it, or to cast it into an integer. And I'm storing that data, the resulting data, into this same variable called data here. So there's a couple of things that can happen. First of all, perhaps there's nothing yet in local storage count, and so the data will then be null. Or perhaps that data is not actually an integer, but it is in fact a string, and so I can't actually, or it's a string that it does not contain an integer within it, so it has that value test, for example. So then parseInt will fail in some way. And so then the very first test that I have after that is, well, is it empty? Is there nothing stored in it? Or is it the case that the value is not actually a number that's stored within this string? So that's what's happening here. If the data is null, or if it's not a number, is NaN, is not a number, then I'm just going to reset the data to be 0. And then from there, I can tell the user how many times I visited that page, and I can continue on from there. I actually store now the reset counter, increment the value by 1, and store that into the local storage count. So in this way, we're able to protect ourselves. So if you're using local storage and you're just storing an actual string, you don't really have to explicitly convert it because it's going to be safe. But if you're actually using other data, whether it be integers or floats or anything like that, you have to be sure to convert it explicitly and make sure that you're actually able to get reliable, sane data out of that conversion and act appropriately, because you're not guaranteed that it's going to function from one instance to the next.
So local storage is taking care of that conversion before we get implicit conversion.
Local storage was not doing the before the implicit conversion. It was just JavaScript. It was just language. It was just the language that was taking this string and just implicitly typecasting it from that string to that integer value before. Yeah, it would not. Right, exactly. So these are primitive types, integers, and it might do floats. But really, this is why I'm saying that it's best to explicitly do the conversion from whatever your object is that you're trying to store in local storage to a string, and then you convert it back from a string to whatever your object is that you want to work with in code. So local storage is relatively basic in that way. It's key value pairs. It stores strings only. And it's up to you and your implementation in your web application to make sure that you work within those confines to safely store and retrieve your data from local storage. Yes?
Is the only context the entire web app, or you can do it for individual pages?
Is the only context for...
I'm asking because if you use a variable somewhere else, local storage, and you use the same thing on another page.
Yeah, local storage is for the domain as a whole. So that means that if I have another web application on the same domain and I happen to be using this same key here, I could in fact obliterate that data from a different web app just by doing that carelessly. So that is something that you'll have to take care of yourself, at least for this basic implementation. All right, yes?
Would it be appropriate to store credentials if you were doing like a mashup and you had different website credentials? And does it have any kind of encryption support? Could you encrypt it before putting it in there?
So would it be okay to store perhaps credentials or other things in local storage? No. there's no support for encryption or anything like that. If you wanted to encrypt, that's again something you'd have to implement yourself in your JavaScript code. Right, you would have to encrypt beforehand, store it safely as a string, then decrypt it from its string form, from the form in local storage. The reason for that is that there's no guarantee that the storage on the web browser, the implementation of the web browser is actually going to securely store that information. Now, in the context of actually sending that data over the web, it's not like a cookie in that it's actually being sent over an unsecured connection to the server. But that's just sort of incidental. That's just because that this is being stored entirely on the user's machine. But that's not something that I would do without actually implementing some encryption or some other method like that. Yes?
What's more of a requirement? Storing the data, validating before you store it, validating after you retrieve it, or both, as far as what the course is expecting?
What the course, what we're expecting? Well, we sort of are, well, you should definitely validate the data before you store it and also when you retrieve it. It's something, basically, what we are going to do is to try to break your code. And so we could do that by perhaps injecting some malicious, or not malicious necessarily, but some bad data into your local storage, for example. And when your web app retrieves it, if you're unable to successfully parse that information, your app just crashes or you get a JavaScript error or something like that, then that's because you did not properly handle that particular case. So yeah, it's a wise idea certainly to check all of your data before you actually start using it, not only for this class, but also in general as well for when you're creating a web app. All right, so we have to move on. So this web storage, this data5.html, is just a very basic implementation of being able to store lots of data. So what if I wanted to, for example, store huge amounts of data, up to 5 megabytes, I actually could. So what I'm doing off screen right now is actually generating a lot of lorem ipsum data. And so I'm just going to paste that here. Like you can see this, which is all just sort of gibberish to us. And I can save that data. And when I refresh the page, what we'll see is, oh, come on. Well, it still has all of that data there, so it must be fetching the data as well. But I could save that data, fetch that data. It's all using these same things, but now it's using much more data just to sort of show you that this is, in fact, being stored locally, and that we can store enormous amounts of data, and that it's also not sending this data from the client up to the server using HTTP requests like a cookie would do. So local storage is really not that complicated. It's pretty easy to use. You just have to check first to make sure that the web browser actually supports it. But other than that, you're good to go. You're ready to store data in local storage. Now, if we can switch gears just a little bit, I do want to talk about another feature of HTML5 that deals with geolocation. So there's another object, the geolocation object, that actually allows you to locate where a user is in space. Yes, did I see a question?
A quick question about the local storage.
Yes.
Do you have to keep track of how much space has been used, or when the limit has reached, what happens when you add another?
So when the limit is reached, you actually have no visibility into how much space you have left in local storage. So when it will actually fail, it will throw an exception that you've run out of storage, and you have to take care of that manually. When you use the set item method, for example, that will actually return, I believe, an exception that you then would be able to handle in this case. So in our case, we're not actually generating; we were just using a counter, so we weren't worrying about that. But if you were actually storing enough data that you were worried about running out of quota, then that's something that you would have to implement yourself as well. Yeah, best practice, right, exactly. I see another question? Same thing, okay. All right, so let's move on then to geolocation. So geolocation is something that it's very similar to local storage in that it is a technology that's related to HTML5, but perhaps a little bit separate. It's implemented using JavaScript, and it's also very cool. So we can see here that when I load this geo1.html page, a box appears up here, cdn.cs76.net wants to track your physical location. This is something that's provided by Chrome, the web browser itself. If you loaded the same page in Firefox or in Safari, it would show you a similar dialog box, but in whatever is specific to their implementation. We can see that as a result, I have two buttons, deny or allow. Now, the thing about geolocation is that you as the web developer, do not actually initiate this. All you do is you just ask the user, you just ask the web browser for a geolocation, and the web browser takes care of this aspect. Now, what's interesting about this is that the web browser will not provide any location to your web app until the user has explicitly allowed that web application access to their physical location. So once I click allow, then what will happen is that it's then going to perform the geo lookup, and then it's going to provide that data to my web app, and then I can do something with that information. So again, just like our other initial examples, it's very simple using an alert box. We can see the data that the web browser is providing to my web app. In this case, the latitude, the longitude, the accuracy, and also the timestamp of when that location was actually generated. Latitude and longitude are in degrees, as you would expect. The accuracy is in meters. Timestamp is actually in this case in seconds, but we can convert all of this using some fancy stuff, as we'll find, or it's not even that fancy.
From when?
I'm sorry?
Seconds from?
Seconds from, it's probably from Unix epoch, but it doesn't, but we'll see how we can convert all of this into something that's useful in just a couple of examples. So here we can see then how we can actually perform the geo lookup. And again, it's very, if you don't actually use any best practices, if you don't actually have any tests or anything like that, it's very easy to implement. And all we have to do is ask navigator.geolocation, which is the object that's provided by, oh, what's going on here? Okay, which is the object that's provided by the web browser for this purpose. We query this getCurrentPosition method, and we pass into it a callback function. So print_geo is actually a function that I've implemented elsewhere that's very similar to that handler function from the Ajax example earlier today, that is called when that position is actually retrieved. The data is then inserted into that, or is then the data is then passed to my function using a parameter, in this case the very first parameter, to that function, and we can do something with it. Now the reason that the callback function is needed is because, as you saw, it's not actually going to pass the data until the user actually allows us to pass that data to the web app, and also because the geo lookup itself might take a non-trivial amount of time to actually complete. So once I get that data, then I have that parameter, in this case that I'm calling POS for position, and then that object actually contains a number of things that we can actually use in our web app. So in this case, we can get the coordinates by using the position.coordinates.latitude, position.coordinates.longitude, the accuracy of those coordinates, and also the timestamp. But there's also other data that might be available to us as well. The only pieces of data that are required by the HTML5 specification to actually be passed to the user are, in fact, these top three: latitude, longitude, and accuracy. Nothing else is required by the HTML5 spec, but a lot of web browsers might actually allow some additional things as well, like, for example, altitude. Some browsers might tell you the altitude accuracy, the heading, if you're actually moving, the speed. So all of these things might be provided by the browser, but just keep in mind that it's not necessarily the case that all implementations will actually do so. So that's something that you'll have to be mindful for. If you're using geolocation, you want access to this data, test to make sure that you're actually getting non-null, non-zero data, and that it's actually useful for you in this case. All right, so again, this is sort of an overly simplistic thing. We obviously want to have some more, some better support for each of these things, and that's exactly what Geo2 does. And it is just a little bit better of a way of doing this same thing. First, we're just going to find out if the web browser actually has that geolocation method, or that geolocation object rather, and if it does, then we will actually fetch the position. Otherwise, we'll notify the user that their web browser doesn't happen to support it. And also now, what we're going to do is supply an error handler to the getCurrentPosition method as well. So notice that the very first method that's actually required by getCurrentPosition, and there's only one parameter that's actually required by this method, is that first handler, that first callback function that gets called on success. So if there was a successful fetch of the geolocation of that user, then the printGeo function will be called. But if anything happens, if the user, for example, denies access to geolocation, if the position for some reason cannot be calculated, then the handler, the error handler, will be called instead, which is the second parameter. So it's always a good idea then to have an error handler function that allows us to find out what the error might actually be. So this is an overly simplistic way of handling these errors. Some error occurred. We could find out from the parameter what the code was and what, if any, the message was that was associated with that. So the way that we could see this happening is if, for example, I actually rejected the user's geolocation, and let's see, location, manage exceptions. Let's say I forgot the fact that I allowed it, and I'm going to refresh this page, and I'm going to deny. Now we can see the error handler in action here. Before, we just would have had a silent failure. Would not have been very useful in that previous example. But in this case, we can see that we did, in fact, get an error that the user denied geolocation. So some of the other errors, like I mentioned before, would be if the location itself cannot be determined, if we exceed some timeout, if we might be able to fetch the location, but it's just taking too long. That's another error message that could happen as well. Did I see a question a second ago?
Yeah, are the error codes standard?
Are the error codes standard? Yes, actually, and that's what we're going to show you in just a few moments here. All right, so here, this is now a better way of implementing this. So now instead of using an alert box, we're actually going to inject all of this data into the DOM. And now you can actually see that we have a better timestamp as well. So rather than just having this raw integer, we're actually converting it to an actual time that might be a little bit more useful here as well. So if we take a look at this code, we can see some of the differences here. And really, we just have a couple of things that are different. In this case, the error handler is now much more robust. We handle those 3 error cases. And in fact, if in the case that those 3 different errors actually occur, we can actually check to make sure that it's one of those and actually have a specific alert message for each of them. And then, of course, a default case for some unknown error that's perhaps not necessarily specified by the W3C specification for geolocation in this case. Yes?
Is the permission session-based, or you can set it up somewhere that you allow a geolocation?
Is the permission session-based? It depends. It's up to the browser. I think some browsers, I think Safari, for example, will limit the location to 24 hours. I think Chrome will actually remember your preference in perpetuity unless you actually explicitly change it. But it's up to the browser. You, as the web app developer, don't know and can't find out unless you're actually testing, unless you just happen to know what it is. All right, but there's also one other thing that I want to point out here, and that is that there is a third parameter that's optional in this getCurrentPosition method that provides some additional options. So you can provide an options object and specify some additional things that might be useful or interesting. So in this case, I've created a new object called ops, and we can see that I'm specifying 3 things. In this case, enable high accuracy is true. Now, the reason that enable high accuracy might not function that well, well, let's see. I suppose just taking a step back, if we think about, for example, iPhones or Android devices, when they use when they're actually fetching geolocation data, the very first location that it might actually have may not be that accurate because it's using cell phone tower triangulation to get a general idea of where that phone actually is. GPS takes a little while for it to actually to get a fix on all of the satellites and get an accurate location as well. And so we can say that by enabling high accuracy that we actually do want to find out what that higher accuracy might be. Not all devices might actually support this particular option, but in the case that the device supports it, then we will in fact want to enable it in this case. So we can also specify a timeout, which is basically telling the web browser how long we are willing to wait for a fix before we actually want it to fail. In this case, the timeout and the maximum age are both in milliseconds. So after 60 seconds, if the web browser can't figure it out, it will actually time out and send an error message to that handler function that I had before. And maximum age is the maximum amount of time that we will allow the web browser to cache that user's position before requiring that it fetches that position again. So it really depends on your web app. Some web apps may not actually need high accuracy, and some of them might allow for an extended amount of time for caching, but you can specify each of these things in this options object and pass it to the geolocation object through the getCurrentPosition method. All right, any other questions before we move on. Yes?
When the allow or deny box comes up, the prompt says that essentially the domain is asking for your location information.
Yes.
But it doesn't seem to me that anything's being posted to that server. So really, it's just your browser that knows your location, isn't that right?
Right, exactly. So all of this is happening locally. So none of this data is actually shared with the server unless, again, like local storage, you actually implement something in JavaScript that pushes that data to a server. But once that data has been provided to your application, there's sort of no promises that the browser can make no guarantees as to what's happening to that data. So I think Firefox, for example, the warning that it provides actually explicitly says that there's the possibility that this data might be shared with the server and could therefore be made public in some way. But that's not something that happens automatically. It's just incidental depending on the implementation that the developer has created for their web app. So all of this stuff, again, is in fact local. And what you saw before when I was looking at the preferences here, we can actually see that this is in fact a local preference that's stored in Chrome that says whether or not I'm going to allow an explicit domain, or a specific domain rather, access to my geolocation. And all of this is all local unless my web application is actually going to push that data upstream. So this is a more interesting example if you're actually looking at it on a cell phone and you're walking around. But this page, data, or rather Geo4, is actually continuously monitoring the position of my computer and is actually updating the geolocation based on where I happen to be moving around. So if I refresh the page, let's see. We might actually see that after a little bit of time it will actually update, perhaps not in this case. But this actually uses a different method. Rather than the get current location, we can actually watch for the current location. And so here we can, the code is very similar, except that instead of using the get current position, we can use this method, watch position. And it accepts the same parameters, the successful callback function, the error handler, and also the options. But there's two key differences. One of them is that this function actually returns an integer. We want to store that integer. We want to remember that integer because when we do not want this position, when we do not want the geolocation object to continue monitoring the position, we actually have to pass it that ID, this ID that's being passed back from this method, to tell it that to stop that particular process from continuing. And also, this will actually happen continuously. This will actually fire every so often whenever we want an update on this data. So here, now the successful the print geo function is exactly the same. It's still being called by this method whenever we have new data, and it's just going to update now this HTML that's contained within that div. But if we actually want to stop that process from continuing, then what we have to do is actually use this clear watch method, which is also provided by the geolocation object, and provide into it that ID that we'd stored above, and that will actually stop this process from continuing. And so the way that we've implemented this is just with a very simple link right here that calls that function that then is responsible for stopping all of this from happening. But if you were to take a look at this on, say, your phone, for example, then you might actually see that this position was, in fact, updated. Now, it's all well and good that we have access to this data, but when it starts really becoming interesting is when we can actually put it on a map. So when we can combine Google Maps, for example, with the data that's being provided to us by the geolocation object, can we actually find out what's happening, or can we actually see what's happening with this data? So in this case, we can see that I have two things. First of all, a marker placed on the position that it says that we are, and also a little circle indicating the accuracy of this particular geo lookup. And now, using Google Maps is actually not all that complicated. If you take a look at the source code for Geo5, you might be able to tear it apart relatively easily. Really, the only difference, we're still using all of this same information, all of these same methods, but now we're just also using some Google Maps code as well to be able to actually place that position data that we're getting onto a map directly. Now, if you are particularly adventurous and you happen to have a cell phone that has not only web access but also but also a GPS chip in it, then you can take a look at geo6.html, which in fact continuously updates. So this is now a combination of, whereas Geo5 really just used that static implementation, that get current position, Geo6 continuously watches the position of the user and will continue to update this map as you walk around or as that accuracy becomes a little bit better. Now there's a couple of notes that I want to tell you about geo implementations in each of these browsers. Safari seems to piggyback off the Mac OS implementation of geolocation, and that happens to require Wi-Fi. So if you are on a computer that's only using Ethernet, it's not going to work. It has to have Wi-Fi because of its implementation. Firefox 4 also seems to require Wi-Fi. Firefox 5, however, does not. They seem to have changed implementations from one version to the next, and it does seem to work using an Ethernet connection. Now, Chrome is interesting because it seems to work fine on wired connections and on wireless, but at least as of a few months ago, versions of Chrome would not allow files that were stored locally on your own computer. So, for example, if you were working on a web app and you had it saved on your desktop and it was not on some server, it was not, even if you allowed the geolocation to be shared with that web app, it would actually continuously fail. So that's sort of another thing that you have to watch out for. So basically what I'm saying is that watch out. There's a lot of implementation differences in the geolocation that can be mildly frustrating from between each of these browsers. So if you're seeing some unusual behavior, try it with some of these examples first to see what's happening in your code, or to see what's happening with your specific browser and computer setup, to see if it might actually be something that's going on with the specific implementation of the browser, or perhaps whether or not you're on Wi-Fi, or any other number of things that could actually impact whether or not the geolocation is going to work. Now, generally, what we find is that it's best to try this stuff on a mobile device if you have an iPhone or an Android device, because it works best on there. None of these laptops have GPS chips in them, so you're not going to get high accuracy out of them anyway. So it's a good thing if you have the device, or if you have a friend with the device, to try it on theirs as a good way to test some of this data, or to test some of these implementations. Now, I just want to show you. I know we're out of time, but I don't want to. I don't want to go over too much, but I do want to show you there is another implementation as well, which combines both of these things, local storage and this idea of geolocation, which you can actually see as the Tracker app, which has these three files: record, show, and show raw. Record is actually very similar to what we saw before. It's just a very basic web page that basically just looks up your information and stores it in local storage. If we look at show raw, this is actually something that allows us to find out what's happening, what's actually stored in local storage, which is a lot of data. We can see that we have latitude, longitude, and an accuracy as well. And all of this is stored in a JSON object that was converted to a string. So it was actually, we use something called JSON stringify to convert this into something that can be stored in local storage. And if we actually want to see what this would look like, show.html will actually put this track on a map, and you can actually see my walk from Harvard Square, albeit it's not super accurate. You can see the sort of squiggly line as I avoided tourists on the way up here, from my walk from the T station up to Northwest Science. And in fact, there are a couple of interesting things that we can learn from this, and that is that obviously I was not walking through buildings here. Well, I mean, maybe that's not obvious to you, but it's obvious to me that I was walking along the street and cold as I was holding my phone. But that's not reflected very well here because of that accuracy problem. If you take a look at the raw data that was stored on the phone, and again, this is all local on the phone, so you can't load up these pages and see the same data. It's all dependent on what you actually store on your specific device. If we actually take a look at that data again, we'll see that the accuracy changed from like 5 meters to 10 meters. So the accuracy really was not that great along the path as I was walking through it, and that's not the fault necessarily of the web app, but rather the data that was being passed from Safari to my web application here. So this is something that's sort of a fun way for you to take a look at your own track as you walk along something. So here we can see now in the recording page that it does ask me if I want to pass it my current location, and you will actually see your latitude, longitude, and accuracy as you walk along. And it does update every few seconds when that data is actually updated. Right now, we're probably not getting good GPS fix because we are, of course, underground. So the accuracy is quite poor, 164 meters, but it is at least giving us a latitude and longitude coordinate. And we could see what the latest track was right here by looking at the raw data. So take a look at the code that's used to implement this. It really just combines the ideas from the later versions of the local storage files and also the later versions of the geolocation files, and just puts it all into one web app that allows you to store and show your own geolocation as you move about. And so with that, thank you all for coming. Next week we will start talking about Android, and rather Java more specifically, and we will continue from there. So until then, see you next week.